Good day, everyone. Welcome to our discussion today. So, we will discuss more on the topic called differentials. So, this is one of the applications of differential calculus where we can use the concept here to find the approximate value of the function at any number, and also to find the approximate values, especially those function that is expressed in terms of radicals. So we have here the objectives of our lecture for today. At the end of the period, we should be able to, the first one is to use the linear approximation to find the value of a function at a certain number and use the concept of differentials in approximations. All right, for the linear approximation, so a curve lies very close to its tangent line near the point of tangency. Now, like in this illustration, so we have here the coordinate system, the Cartesian coordinate system. We have the x and y axis, and we have here the graph of the function y equal to f of x, the one that is in blue color, and the other one in a purple color is the tangent line given by this equation y equal to L of x. So we have here the point is the point of tangency with the coordinates a and f of a. All right. Now, as we look at this picture closely, so we can say that by zooming the picture, we can say that the graph of the function becomes more and more uh, uh, like its tangent line, right? Especially for this part here. All right. So by zooming in toward the point on the graph of a differentiable function, we notice that the graph looks more and more like its tangent line, as you have seen, especially on this part here, class, right? So this observation is the basis for a method of finding approximate values of a function, especially in this part here, class. So if you look at this part here, so you see here, if you look at closely, this part here, so the curve y equal to f of x more like its tangent line, right? So it means that if you are going to find the value of function, so here we have here the uh, point of tangency with the coordinates a and f of a. So it means that um, it means, class, that a here is the distance, no? That is the distance from the y-axis towards that point. Okay, so this is the a. Okay, so ito yung a, class. And from the x-axis towards that point, okay, so this is our f of a. So from the x-axis towards that point, or the height of this point from the y-axis, so that is our f of a. So that's why the coordinates of this point of tangency is a, f of a. Okay. All right. So this is the illustration class that we can use this concept, no, to find, for example, if you are asked to find the value of the function, the value of the function, whether this is our a, say for example at this point here, at this value of x which is closer to a. Say for example you have here the, say, a1. So definitely a1 is less than a, with respect to the origin, and then you're asked to find the value of the function. So at that point a1, all right. So, or it can be here. Say this is your a2. So if this is your a2 and you're asked to find the value of the function at x equal to a2. So what is the value of the function at this point here? All right. So instead of using this y equal to f of x, we can use a tangent line, no, to find the value of the function, approximate value of the function, where a1 and a2 is closer to a, because there are times, class, that it's easier to find or difficult to find the value of the function that is closer to a, either from the left towards a or from the right towards a. So we have the method on how to find that, to find the value of the function. Okay, so the idea is that it might be easy to calculate a value of f of a, or value f of a of a function, but difficult or even impossible to compute nearby values of f. So we settle for the easily computed values of the linear function L, whose graph is the tangent line of f of the function at the point of tangency with coordinates a, f of a. So we use the tangent line at this point of tangency as an approximation to the curve y equal to f of x when x is near a. So it can be coming from the left towards a or coming from the right towards a. So an equation of this tangent line is given by y equal to f of a plus e prime of a times x minus a. And the approximation, we have here the approximation f of x, or function of x, approximately equal to f of a plus e prime of a times x minus a. So we have y approximately equal to f of x. So we can use the tangent line instead of the, the function y equal to f of x, all right, to find the value of the function at a certain number. Okay, so the linear function whose graph is in this tangent line, that is f of x, or function of x equal to f of a plus e prime of a times x minus a, is called the linearization of f at a. Linearization of f, linearization of the function f at a. All right. Now, for example, if you are given, say, here, square root of 3.98 and square root of 4.05. So find the linearization of the function given f of x equal to square root of x plus 3 at a equal to 1, and use it to approximate, right? So use it to approximate this square root of 3.98 and 4.05, square root of 4.05. And then after that, after you obtain the approximate values of these two given radicals, then you have to find out whether these are overestimates or underestimates approximations. Okay, so our solution here, the first thing you do is to just to give you an idea of what this graph is. So you have to graph this by there are at least two methods class. One is you assume values for x and then you solve for f of x. Then after that, you plot the points. So after plotting the points, then you can connect the points and you will form this graph. Okay, so this is one method class, although there are other methods on how to graph the function. Okay, so for example, if you here in this given we have minus 3, so when x equal to minus 3, so we have f of x. So in this minus 3 plus 3, 0, square root of 0 equal to 0. So that's why here our first point is at this point here. At x equal to minus 3, we have f of x equal to 0. So at this point. And we are given here at a equal to 1. It means that this is our a here, right? This is our a. So the value of our x, so our x is equal to a, equal to 1. So at x equal to a, where a is equal to 1, okay, so you can use also this value class. And if you're really familiar with this equation or this function, then you can easily determine, right, what kind of equation is this, and when you graph that, what kind of picture you will see. So actually this is a semi-parabola class facing, no? Semi-parabola facing to the right. Okay, so assuming you know that, then the next thing to do is to find the equation of the tangent line, because this equation here, y equal to square root of x plus 3, this is the equation of the graph of the function. Okay, so now what is the equation of this? So we have here y equal to 7 over 4 plus x divided by 4. So paano ba yan? Saan ba yan galing yan? So that is the thing that I need to uh, give you details on this part. Okay, but for now, I'll just show you, the complete solution of this problem. So once you obtain this equation of the tangent line, then since we know that y is a function of x, and we know that the equation of this tangent line is approximately equal to the equation of this function, y equal to square root of x plus 3. So therefore, we can say that the square root of x plus 3 is approximately equal to this is the equation of the tangent line. All right, and then you have to break this into two parts, expressing in terms of x plus 3. You have something then plus 3, so that something is your x. All right, and also here you have to express this also into something square root of something plus 3 also, and then that something is your value for x. All right, so here's the complete solution. The square root of 3.98 approximately equal to 7 over 4 plus 0.98 plus 4. So where is this 0.98 coming from? So actually this is coming from here. So you break this into square root of uh, x, x plus 3. So you have one part here which is equal to x, the other part is 3. So what is the value of x such that when you add that value of x to 3, you will have square root of 3.98. Okay, so that's the question. So the answer is for that is, so we can break this into something which is, that something is 0.98, right? So you have 0.98, then you add it to 3, so what will happen? So that is 3.98. So therefore the 0.98 class, so this is our x actually. This is our x. So that's why in our equation, so this is the value that we have substituted here. So because the tangent line is 7 over 4 plus x over 4, where in this case, now for this part here, we break this into x plus 3. So we have plus 3, then something or something here, which is equal to x equal to 0.98. So we have here the value of x equal to 0.98. So substituting, we have square root of 3.98 approximately equal to 7 over 4 plus x, where x equal to 0.98, this one here, divided by 4, and we have 1.995. Okay, so before solving this, you have already an idea of what is the answer here, because square root of 3.98, this is very close to square root of 4, right? So when you have square root of 4, so what is square root of 4 equal to? So the square root of 4 equal to 2, right? So since the radicand is less than 4, so we can expect that our answer is less than 2. So may idea na tayo kung anong answer dito. So that's why when we do the calculation, we come up with uh, the square root of 3.98 is equal to 1.995. Okay, now for this part here, okay, so for this part, so again, you have to break this into square root of x plus 3. Square root of x plus 3. So what is that? No? What is that value of x such that when you add it to 3, you will have 4 square root of 4.05. So meaning you have something, then plus 3, and the result would be this one, right? So that will be your x, your something here. So this is 1.1.05. So this is 1.05. So therefore, that's something that we are talking of. So this is our x. All right. So substituting. So we have here square root of 4.05. So again, this is equal to the tangent line equation. 7 over 4. Originally, this is 7 over 4 plus x over 4. But our x this time, no, our x for this uh, given is equal to 1.05. So 1.05 divided by 4, then plus 7 over 4. So we have here 2.0125. Okay, so from the given alone, we can expect that the answer is more than 2 because square root of 4 is equal to 2. Now this is more than 4. This is greater than 4. So square root of that, we can expect our answer to be greater than 2. So that's why here in our calculation, so we got here uh, equal to 2.0125. Now the question is how this tangent line. Kasi on this part here, madali lang to eh. You just break this radicand. Radicand class is the number inside the radical symbol. Radicand ang tawag niyan. So we have to break that up into, so whatever is the given function, no, in the problem. Like this one, we have f of x equal to square root of x plus 3. So then you have here a radical that needs to be, or the value of the radical that needs to be calculated or approximated. So we have to break this radicand into two parts in terms of, we have something which is equal to x plus 3. So it means that we have that something, when you add it to 3, so the sum should be equal to the radicand. Okay, so that's why we have here that something which is 0.98 plus 3. So finalo lang natin to. So that is 3.98. So that's something, 0.98, yun yung x natin. So this is the value that we need to substitute here in the equation of the tangent line. Alright? So now the problem is how to get this, where this equation coming from. So that's what I'm going to discuss to you in details. Okay? Alright, so class, we have seen already the graph of the function, but I will still draw it again here. So we have our x, and this is our y. So again, our y is a function of x, so that's why we have here y equal to f of x. And our graph, the graph of our function is something like this. It's a semi-parabola facing to the right. And we have here the point of tangency. Okay. And we have here the tangent line. Okay, so this is our tangent line. Oh, sorry for that. So this is our tangent line, TL. Okay, so in our previous illustration, we know that at this part of the graph, our function y equal to f of x is more like its tangent line, right? So that's why we can solve the value of the function using its tangent line instead of the equation of the given function. Okay, so here we know that this is given. We're given a here because the point of tangency is 1 and 2. So where did we get this 1 and 2? The coordinates of this point of tangency. So we are given a equal to, we're given a equal to 1. And we are given the equation f of x, right? F of x equal to square root of x plus 3, right? Now at x equal to uh, at, at x equal to a, so our function becomes f of a equal to square root of a plus 3. And the problem we are given in our problem, so given a equal to 1, right? So therefore the value of the function when or the value of the function at x equal to 1 or at x equal to a, where a is equal to 1, so we have f of 1 equal to the square root of 1 plus 3. So what is square root of 1 plus 3? So 1 plus 3 is 4, so square root of 4 is equal to 2, right? So that's why we have here the value here 2, right? So this is f of 1. So take note our f of 1, so this is just our y. This is just the ordinate, right? So the coordinates of this, so therefore if we call this point here as our p1, if we call this point as our p1, so p1 in our analytic geometry, so we have coordinates x1 y1, right? Now if you can still remember from your analytic geometry, so if you call the point p1, so you have the coordinates x1 y1. So therefore our x1 here for this particular point, so our x1 is equal to 1, all right, and then our y1 is equal to 2. So y1 is equal to 2. All right, so we will be using these values here when we find the equation of the tangent line. Okay, so in our calculus, when we speak of slope, so when we speak of slope, that is just the derivative, no, the derivative of a given function. So we're given y equal to f of x, where our f of x is equal to square root of x plus 3, right? So you can also express this as is the same as x plus 3 then raised to a power 1 half, correct? So x plus 3 raised to a power 1 half. Now when you are going to differentiate this or take the derivative of this function, so we have y prime, or we have dy over dx. So y prime, which is equal to dy over dx, which is equal to f prime of x, and that is the slope of the tangent line. So derivative this using the power rule. So we have 1 half times x plus 3, then raised to a power, what is 1 half minus 1? So 1 half minus 1 is negative 1 half. And then if you bring this down, so maging positive siya, and then 1 half means square root, no? If the power is 1 half, so that means square root. So therefore we have y prime equal to 1 divided by 2 times square root of x. So this is our slope. Okay, so this is equal to our m, slope of the tangent line. All right, so solving for the slope of the tangent line, m is equal to 1/2, so 1 over 2 times, so square root of x. So what is our x? Okay, so what is our so this is x plus 3 class. So x plus 3. So at the point of tangency, our x is equal to x1, we equal to a, which is equal to 1. So this is equal to 1. So 1 plus 3. So 1 plus 3 is equal to 4. So square root of 4 equal to 2. Then times 2, that is 4. So therefore our m is equal to 1/4. Okay, class, just to remind you that we are solving for the equation of the tangent line. So now to find the equation of the tangent line, so we need to use the concept that we had now learned from our analytic geometry. So we'll use the point slope form. So why we choose to use this? Because we are given the point, no, the coordinates of point 1, 2, point of tangency, and we have here the slope. So to find the equation of the tangent line, so the best form that we should use is the point slope form. So can you still remember what is that point slope form? Can you still remember the point slope form formula? So from our analytic geometry, the point slope form is something like y minus y1 equal to m, no, slope of the line, in this case our slope of the tangent line, times x minus x1. Okay, now substituting, so y minus our y1 is given us, our y1 is 2, so y minus 2 equal to m, our m is equal to 1/4, so substituting m equal to 1/4, then multiplied by x minus x1, our x1 is equal to 1. Okay, then here we need to express y in terms of x. So to do that, let us sub or add both sides by 2, or you just transpose, no? Transpose this -2 to the other side, then change the sign. So we have, therefore on the left side we have y equal to, this is -2, so when you transpose that, that becomes +2, then plus, so I have here 1/4 times x, you just distribute this and multiply to each term of the inside the quantity. So 1/4 times x, so that is 1/4 x, and then 1/4 times -1, so that is -1/4. All right, so we're now very close, no? So combining this 2, +2 here, and also the -1/4. So what is 2? No? 2 minus 1/4. So what is the answer for this one? 2 subtract 1/4. Okay, so 2 here is understood to be over 1. Okay, so we have here, find the LCD. LCD is 4. So 4 divided by 1 is 4, times 2 is 8. Then 4 divided by 4 is 1, times -1. So that is -1. So 8 minus 1 is 7. And 7 divided by 4. Alright, so we have here 7 divided by 4. So therefore, we have y equal to, so the combination of this 2 and minus 1/4 is just 7 over 4. Alright, then plus, we have 1/4 x, or simply x over 4. So this is now the equation of our tangent line. So ito yung ginamit natin kanina, class, no, to calculate. So it means that, no, from the principle or the concept that we had discussed earlier, so instead of using y equal to square root of x plus 3, so we opt to use this, because this is the function, no? This is the function, the graph of the equation of this graph, and this is the tangent line. Okay, this is the equation of the tangent line. And then, as mentioned earlier, as we discussed the concept, that as we look at closer, no, the graph, we can say that when we magnify, no, when we zoom in the graph and zoom in the point, we can see that the function become more and more like its tangent line. So instead of uh, using this one, so we can approximate that our y, since y is equal to this one for the function and this is for the tangent line, so we can say that square root of x plus 3, or square root of x plus 3 is just approximately equal to the tangent line. The tangent line, which is in this case 7 over 4 plus x over 4. Okay, and then we did the calculation as we did earlier. All right, So that's it. That's the details of the solution class. And we just make the shortcut in the previous slide here. So to calculate this one, so just use the tangent line. All right. And then break this up into two parts like what we did here. And that something here is the value for our x. And then substitute it here. Then you get this. And so do with this number here. Break this in two parts. All right. And substitute in our equation of the tangent line here. These are equation of the tangent line, which was discussed in details, no, a while ago. Okay, so that's it. No, I think it's already a long video, so I have to cut up to this point, and I will make another video for the second part of this, no, for the second objective of this topic. Okay, so thank you very much, and see you in the next video. Bye.